Every serious AI companies are implementing Model Context Protocol. If you are not learning Model Context Protocol, you are already behind. 95% of MCP videos on YouTube are vague. They are beating around the bush. In this video, I explain step by step where LLM fails. That is where we need MCPs and AI agents, the main architecture of MCP, and we'll walk through a real life example of MCP based AI agents. I'm Shorin, an AI engineer, and this might be the most important technology you learned this year. So let's dive in. First, let's understand what are the shortcomings of LLMs and why do we need AI agents and MCP servers. LLMs are large language models like ChatGPT. They are super smart robots that has read lots and lots of words. They learn by looking at patterns in sentences. They can talk to you, answer your questions, write stories, and can help with your physics and mathematics homeworks. So how do they learn? Imagine feeding your robot with huge library of books and movies and songs and pictures and so on. It reads billions of sentences from books and websites and more. So LLMs try to predict the next word. That is how they work. Like when you input the cat sat on the, they will try to predict the mat or sofa or bed and whatever. That is how they work. Now let's see what are some problems they have so that we need AI agents and MCP servers. First, they don't know anything about your problem. I mean, they don't have context of what problem you are going through. Let's say you ask ChatGPT that, hey ChatGPT, how do I cook chicken? ChatGPT doesn't know what are the ingredients you have at your home. What are your cooking skills? So when you input those things like these are the ingredients I have available in my home, I am a beginner at my cooking. So that is when ChatGPT will give you better result. Second, when they doesn't have the answer, they keep on hallucinating. I mean, when they do not have the exact answer for your question, they keep on beating around the bush. And third limitation is they cannot perform any task on behalf of yourself. Like, can you go to ChatGPT and ask it to schedule a meeting on your Google Calendar? No, right? The same way, you cannot ask a LLM or ChatGPT that, hey ChatGPT, write this email and send it to this person. No, they cannot do it. That is the limitation. That is where we need AI agents and MCP server. So let's dive in and see what are MCP architecture. MCP is Model Context Protocol. It helps small robots to talk better and work together with different types of apps that are integrated with the LLM. So let's see what are the three different components of our MCP architecture. So first, host, the boss of the party. The host is the main controller. You can think of host as a principal in a school who organizes everything, who controls everyone in the school, and who performs every activity that is going on in that school, right? So that is how the host works. You can see the note. The host is the main controller. It brings everyone together, the model or the LLM and the tools and apps. It holds conversation memory or context. What host does? It stores all the messages in the form of context. It decides when to use what tool and keeps the chat flowing smoothly. So the second part of the architecture is server. And what is a server? Server is the tools that we are going to use with our AI agents like the calendar app or the calculator app or web search application. Like when we are going to ask our AI agent that, hey AI agent, schedule a meeting. It's going to use the calendar tool, right, to schedule a meeting. So that is how the tools work. So that is what we call the server. Another kind of tool that can be databases that we also call a server. So now what server does? Server keeps tools ready for action. It waits for the model to call them and run the tools when it requires. So now see what is this client. The client in the architecture is the one who talks to the tools as well as to the host. They keeps the connection alive between the host and the server. It sits together with the host itself. You can think of client as the person who maintains communication between the host and the server. So now what the client does? It keeps one-to-one connection with the server or the tools. It gets replies from the model, keeps the connection alive. Now let's discuss few more things about this, about what server does. And now I'll call it MCP capabilities. So Model Context Protocol lets AI agents work smartly by using different capabilities. These are like tools in a toolbox. And there are three different types of MCP capabilities. As we discussed before, the MCP server, they can be of three different types. First, the tools. Second, the resources. And third, prompts. So first, let's discuss about the tools. As I told you before, the third-party tools we're gonna use, like Google Calendar, or let's say a calculator app. That would be the tool. Let's say we are building an AI agent that can tell us about the weather. So this would be the Python code for that particular AI agent. Let's say now let's talk about resources. Let's say we are building an AI agent for medical purposes. We have to teach the AI agent about medicines and etc. So now we have to supply the AI agent with some resources. So this is how we will write a Python code to supply the resources for the AI agent to read and follow the instructions. Third, prompts. These are the instructions on how AI agents should behave. These are supplied via code, as you see. If we are building a code review AI agent, this is how our AI agent instructions will look like. And why the prompts are supplied to the AI agent? It gives a pre-designed format for the AI to perform. It makes the performance better, and also it gives a controlled and well-developed performance. And now let's see in the workflow of MCP-based AI agents with an example. So first, when the user asks something to the AI agent that, "Hey AI agent, schedule a meeting at 8 p.m. in my Google Calendar." Second, what happens? The host listens and prepares. The host we discussed before, the principal of the school. The host app catches your message and says, "Okay, let me perform it." So it takes your message and wraps it in JSON format along with the prompts that the developer have supplied, and if any previous message existing. And in our case, we do not have any previous message. We have only prompts that the developer have supplied. Third, the JSON data has gone to the LLM, and the LLM understand the problems. The LLMs get the data formatted, and it thinks what tool it can use. What are the tools it has in its gallery, and what are the tools it can use for the specific task to perform. Fourth, LLM calls the tool. The LLM decides which tools it requires to perform the task. You see, please call the Google Calendar API and create the event at 8 p.m. After deciding the tool, the host passed this tool call to the MCP server via MCP client. And the MCP server or the Google Calendar tool, after getting the request, performs the task using the Google Calendar tool. And now the task has been completed and your meeting has been scheduled at 8 p.m. in your Google Calendar. This is how the MCP works. I'll see you in the next. Bye-bye.